problem set. So we're going to go through, I think, 8 and 14, the first step here. So let's get right into it. So what is the octet rule? This one's a pretty basic question. We're going to go, octet rule, octet meaning 8. So what's important to know is that any, like neon, let's just take a noble gas as an example. Neon has the outside energy level is 2s2, 2p6, and there's where our 8 comes from. The 2 plus the 6 equals 8 electrons. And what the octet rule is stating is that elements will lose or gain electrons to get to 8 electrons on the outside. Okay, or get a noble gas configuration. So that's what we're talking about. It's the whole reason why sodium has a +1 charge, because it gets rid of 1 electron, so it looks like neon. So we're going to see this pop up over and over and over again, we're going to carry that through to B. How many electrons must sulfur atom gain to achieve an octet in its valence shell? Well, sulfur is argon, 3s2, 3p4. So 3s2, 3p4, if I add these top two numbers here and here, obviously I get 6, so I need 2 more electrons to get to 8, which is where they go here. So I go 3p, and then what you see is this is one way to do it. There's the first 3. The fourth one goes here to finish up that orbital, and then I have a spot here and here for an extra electron to go here and here. When that happens, then sulfur has a -2 charge, which is why in most cases in compounds sulfur has a -2 charge, which is where we get the crisscross from like hydrogen sulfide. All right, moving on. C, if an atom has electron configuration of 1s2, 2s2, 2p3, how many electrons must it gain to achieve an octet? Well, again, 2p has 1, 2, 3 orbitals. I got 1, 2, 3. Notice I'm spacing these electrons out. That was from Hund's rule. Remember, electrons are negative by nature, which means that they repel each other because of the same charge. So they will spread out across orbitals until they have to pair up, which that means, then getting back to the problem, I have 3 spots here where I can fit in an extra 3 electrons. So how many electrons must it gain to achieve an octet? So here we can gain 3 electrons, and this is why nitrogen as an anion has a -3 charge. Okay, let's keep going. And we'll keep this nice and short. Use Lewis symbols to represent the reaction that occurs between magnesium and bromine. So I'll start off with magnesium. Magnesium has a dot diagram of 2 because magnesium's in the second group, which means it has 2 valence electrons. We're going to add that to bromine. I'll switch colors so that you can see. Bromine is in group 17, which means it has 7 valence electrons. Here are the 7. I have 2, 3, I got 3 groups of 2, and then an extra spot right there for one of magnesium's electrons. So if one of these electrons comes over here and fits in this spot, that's an ionic bond. Clearly, I'm going to need 2 bromines because I have 2 extra electrons, and each bromine only houses 1 extra electron like that. Okay, so this would be the Lewis symbols to represent the ionic bond that happens between magnesium and bromine. And then on the other side, I end up with magnesium down 2 electrons, which means it has 12 protons and 10 electrons, which is where the +2 comes from. And then here I have 2 bromines. Each one has a -1. Okay, back in chapter 2, we talked about making compounds, and we talked about crisscross. One of the easiest ways to do it was to move the 2 down as a subscript. This is the whole reason why we do that. So this is the description of why we do the crisscross to make the compounds. Notice that magnesium has a +2 and I have 2 bromines with a -1. Where did I pull that extra bromine from? Some students ask that, like, where's that bromine come from? You just make up a bromine benzene? Well, if there's one bromine atom, there are more than one bromine atom. So all the rest of the bromine atoms would not be attracted to magnesium, or at least not get an electron from magnesium, because magnesium only has 2 electrons. So I pulled another bromine from the environment, and you can do that because atoms are very small and very plentiful. So I'm going to stop there and start with 26 for the next round, because this is a long one. I'll probably do this one by itself.